Hello everyone, welcome to IMS GATE Academy. Good morning. My name is Deepak Arora, and in the continuation of our series for the Engineers Day Special, I'm going to solve some questions of previous GATE years for the subject Transportation Engineering. If you see the last few years, means if I say the last 5 to 6 years, we have seen the very high weightage of the subject Transportation Engineering. If I say before 2015 or 16, the weightage was maybe 7 to 8 marks or 6 to 7 marks. But in the last 3 to 4 years, we have noticed that the subject weightage is almost 11 to 12 marks. Okay. And if I say our series name is Smart Method to Solve the GATE PYQ, right? Many times maybe you heard the word tricks, right? We say there's a trick of solving the question. So I don't mean that it's a trick. Maybe it's a concept only, but we don't know the concept in that way. So we say it's a trick. Ultimately, everything is concept, and we have to understand the concept in a multiple way. Concept is not like if I write one definition of any topic, that's it. No, it can be the other way. It can be the other way. We have to think, and that thing we will implement today in some questions, so you will better understand how to approach. We are here to tell you how to approach the questions. Okay, means we cannot say this question is going to come or this topic is going to come. We cannot be sure. But yeah, how to approach the questions. So definitely next one may be helpful for you. Okay guys, so if you have any doubt in the between the sessions, you can put in a chat box. I will revert back to you, and just focus on next 1 hour. I promise you, in the next 1 hour, 5 to 6 marks definitely of 11 in a transportation engineering, you will ensure that. Okay, yeah, one more thing I want to add here. The time management is the most important factor in a GATE exam. Transportation engineering beauty is this: if a subject comes for 10 marks, you can solve the question maximum in 10 minutes. If subject comes for 12 marks, it will not take more than 12 minutes. Means I can assure you 1 marks in a 1 minute you can assure easily in this subject, because questions are not at all lengthy. All the questions can be done maximum into the 3 to 4 lines, and that we will see now. Okay, so let me start. I have taken some few questions of a GATE previous year. Like this question came in a GATE 2016. One second. This question came in a GATE 2016 set by the IISc Bangalore that time. Okay, so if, just a minute, if you read the questions, if all of you read the questions, see, the question is saying the critical flow ratio for a 3-phase signal are found to be 0.3, 0.25 and 0.25. The time lost in the cycle is 10 seconds. The effective green time in the seconds round off to the nearest integer for the 3 phases are. We have to find the effective green time of all the phases, because we have a total 3 phases and they have given the critical flow ratio. So if they have given the critical flow ratio, so definitely we know the critical flow ratio used in a Webster method only. And if you see the last 5 to 6 years, if I say 10 years, every year almost we get the question from this topic, Webster method, right? So what is Webster method? What is Webster method? As per Webster. So the principle of Webster method is the delay should be minimized. Any signal, if you design or the basic agenda is the delay should be minimized. So what's the formula for Webster method? C naught is equals to 1.5 L plus 5 upon 1 minus Y, right? So C naught is optimum cycle length, 1.5 into L. L is what here? L is the total lost time. Total lost time means lost time of all the phases. In this, the mostly students do the mistake. They consider whatever the question have given directly. No, you have to see they have given the lost time of all the phases, or they have given per phase. If they will give you the per phase, you have to convert for the all the phases. If they give you the all the phases, that is okay for me, right? And 1 minus y term will come how many times? Whatever the number of phases are there. So here question said to you 3 phases are there. So it will be y1, it will be y2 plus it will be y3. Right, so if you see here, C naught is equals to 1.5. Let's put the L value first. So L value, if you see, question have given how much to us? 10 seconds. The total time lost in the cycle is 10 seconds. So 1.5 into 10 plus 5. So here you can see, question have given lost time for in the cycle. Cycle meaning all the phases are included, and 1 minus y is what here? Y is the critical flow ratio. So how much they have given? 0.3, 0.25 and 25. Let's put the value here. 0.30 plus 0.25. 1 minute. Something is wrong. Just a minute. So here if I say C naught is equals to 1 minute, just give me a minute. So here if I say C naught is equals to 1.5 L plus 5 upon 1 minus y, and C naught is equals to 1.5, L value is 10 plus 5 upon 1 minus, and critical flow ratios are 0.3, 0.25, 0.25, 0.30 plus 0.25 plus 0.25. Okay, so if you solve this, can you tell me, anyone, how much it's coming? Can you tell me how much it's coming? Can you tell me how much it's coming? So to solve this, it's going to come 100 seconds. It's going to come 100 seconds here. Okay, so in 100 seconds, now what they are asking to us? They are asking to us effective green time, and we know the formula of effective green time, right? So G1 is equals to what we know? G1 is equals to y1 upon y into C naught minus L, right? Y1 is what? Y1 is the critical flow ratio for first phase, so that is how much? 0.30 upon y is what? Total summation 0.30 plus 0.25 plus 0.25 into C naught minus L, that is 100 minus L is 10, right? 0.30 plus 0.25 plus 0.25, it's coming 100 seconds here. Okay, so here we can solve. Similarly, G2 you can solve. Similarly, G3 you can solve. But I don't want to solve in this way, right? If I solve in this way, so definitely it's not a smart way. So here we have 100 seconds, and you see options are given to me here, right? Options are given to me here: 34, 28, 28, 40, 28, 28, 40, 30, 30, 34, 25 and 25 here, right? So I know the total cycle length is how much? Total cycle length is how much? 100 seconds. And what is the meaning of cycle length? What the meaning of cycle length? Cycle length meaning is summation of time allocated for each phase here, right? So now you will say, sir, we will do the summation, and whatever the 100 will come, that will be answer. Like if you see the option C here, that is 30 plus 30 plus 40. So you can say, sir, 30 plus 30 is 60 plus 40, that will become 100. No. Here what the students do the mistake. Definitely the cycle length is 100, but we have to include this 10 seconds also. The 10 seconds are also there, right? 10 seconds are also there. You cannot ignore the 10 seconds here. So what we do here, we have to check the option in which cycle length will be how much? Not 100 seconds. It will be 9 options we have to take, in which all the summation is 90 seconds. Why 90 seconds? Because 10 seconds are allocated for the lost time also. So now you can see which option is correct. You can tell which option is correct here. In which option summation is coming 90. If you see here, 28 plus 28, 56 plus 34, it will become 90, and definitely answer A is correct. Option A is correct. If you want to solve by this way, if you want to apply the formulas, you can apply the formula also, no problem. Okay, you can apply the formula, I have no problem. But thing is, you can solve this question in a maximum 15 to 20 seconds. Once you know the C naught value, it can be done with the help of options only. So here option A will be correct, 34 plus 28 plus 28. No need to do anything else, right? So this is the first question. So here if I say direct, if you want to apply, you can apply the formulas also. I have no problem with that. So option A is correct here. Option A is correct. Why option A is correct? Why option A is correct? Because total cycle length will be equals to what? G1 plus G2 plus G3 plus lost time of all the phase. So here you can see C naught, how much we got? 100, and G1 plus G2 plus G3 will be equals to what? Total last time is how much? 10 seconds. So you can see here G1 plus G2 plus G3 will come 90 seconds, and only one option is there which is satisfying this 90-second condition. Now the question may come in your mind, sir, if they have not given options, can we tell directly? No, beta, you cannot say directly. Then definitely you have to apply the formula. G1 is equals to Y1 upon Y into C naught minus L. Then you have no other choice by applying the formula. You have to apply the formula. Other than that, we can't do anything in this one. Okay. And Webster method is one of the most important topic continuously coming in the gates. Don't miss, only two formulas are there in the whole method, and 2 marks question we have seen last year, last to last year, every year we are seeing the question. Okay. So let's proceed to the next question. The next is, again, this is the very good question, came in a GATE 2020. This question came in a GATE 2020. What the question? The flow density relationship of a traffic on a highway is shown in the figure. The correct representation of speed density relationship of the traffic on this highway is. I put this question in the best category which the question have came in a transportation engineering in the last years. Okay, a really good question, right? So flow is given to us, density is given to us. Flow, what we say? Flow generally we denote with a Q, and density we denote with a K. It's a Q and it's a K. Now you think how to solve. The question is looking like to you, it's a transportation engineering question, right? But technically it's a mathematics questions. Only one concept is required from transportation that I hope all of you know. Q is equals to K into V. What is Q here? Traffic flow. Traffic flow is equals to traffic density into traffic speed. So here I telling you one more point. Traffic speed meaning is what? Traffic speed meaning is here space mean speed. This concept the GATE used in last year 2022. They have given the two types of speed in the question, time mean speed and the space mean speed, and they ask you to pick any speed which was required in the question. So always if the question gives you the both speed, we have to pick always the space mean speed. Time mean speed have no significance in that one. Okay, so now come to the question. So as I said, the question requirement is only and only mathematics. So we have to convert QK graph to VK graph, because speed is what? V and density is what? K. So how can we convert? Simple mathematics. You can see here in a flow density graph, initial line is, if you see initially what is there? Initially you can say, initially it is given to you straight line, right? Initially they have given you here straight line, right? So let me put some value here. Let us say here density is K1. I don't know. I'm just assuming some value. And here density is, let us say, K2. And here the flow is, let us say, Q1. Okay. I am just taking the randoms. Here K1, here K2, and here Q1. Now if I focus the initial straight line. So what is the equation of straight line? You know. y is equals to mx plus c. All of you know. On y-axis, what is there? Q. So Q is equals to m. Let's put m only. X-axis, what is there? K. And you can see if any c value is there. Definitely not, because it's starting from origin. So c value will be 0. So I can say here Q is equals to m into k. M is what here? Slope. So definitely slope we can calculate here. What will be that slope? Slope is what? Tan theta. So what will be slope here? You can see in this triangle. Definitely it will be q1 by k1 into k. So definitely can I say q1 by k1 is what? Q1 is some constant. K1 is also some constant. So I am saying, let us say it's a alpha constant. Yeah. So q is equals to alpha into k. This equation I got in between Q and K, but what I want the answer V and K. I know Q is equals to K into V. So Q is equals to K into V into alpha into K. So K to K cancel. V comes how much? Alpha. Alpha means what? V is constant. V is constant. So you see, for the initial straight line, V is constant in which option? Definitely A is not possible. You can see it's decreasing here. B, definitely it's a constant. C, again it's a constant. D, again it's a constant. So all three options are possible. So we have only eliminated option A. Other three options are possible: B, C and D. So now how to check B, C, D? Again same thing here. What same thing? Write the equation. No, write the equation. So again, if I say for second part, I'm solving here. So again, I know y is equals to mx plus c. Again, I know y is equals to mx plus. On y-axis, q is there, and m into x plus c. M, you can see here now in this second line. This second line is what? It's a decreasing beta. It's a decreasing. So definitely the slope will be, if it's a decreasing, the slope will be positive or negative? Slope will be positive, negative? Definitely slope will be negative. And what is the slope value? Again, it will be some constant here. Okay, again it will be some constant. What will be that constant? Okay, let me write the constant. So in this triangle, now you can apply the tan theta. So it will come how much? Q1 upon K2 minus K1. Because this length will be how much? K2 minus K1 into x. On x-axis, what is there? K plus C. Is C 0 here? Is C 0 here? Is C 0 here? No, here C is not 0. Why? If you extend this line here, so this part will be, this will be our C. This will be our C. How can we find this C? You can see this is the complete bigger triangle. If you consider, what C value will come? This is my C, and this is theta. Theta means what? This value I know. And if I multiply with K2, so definitely it will be m into K2. M is what? Slope only. So theta into K2 will give us C value. Okay. So now you can see here Q is equals to, again, Q1, K2, K1, complete constant with the negative sign. So minus alpha into K, M K2, M is constant, K2 is constant. Both will become other constant. Let me say any constant beta. Okay. So this I got again in between Q and K. I want in between V and K. So Q is equals to K into V. It's equals to minus alpha K plus beta. So V is equals to minus alpha plus beta upon K. Minus alpha plus beta upon K. Now what is this equation? This equation is for which curve? This is the equation for hyperbola. This is the equation for rectangular hyperbola. So GATE have given you some relaxation here. GATE have not mentioned what is the degree of this curve. If GATE have mentioned it's a parabola or ellipse or circular, so definitely you will be in trouble. But here definitely GATE have not mentioned. GATE have just mentioned it's a some curve is here, and this curve is what we can see. It's a hyperbola. Now the question comes in the mind, which hyperbola? Because definitely C is not possible because it's a straight line, but again B and D is possible. In a B it's a downward, and D it's a upward. So it's always depend upon beta this sign. You can see here we got a plus, here we got a plus. Plus meaning what? Plus meaning what? It's a upward. Minus means what? It's a downward. So here you can see option D is correct. Here you can see option D is correct. Why option D is correct? Because it's a rectangular hyperbola and it's a positive sign, so that will be upward, not a downward. Okay. Now you can see, sir, it will take time. Definitely not. If you are good in a mathematics, just by seeing that, definitely you will not take maximum 10, 20 to 30 seconds for writing any equation. It's clearly visible to me what is the straight line equations we are studying from the 9th standard. Okay, so straight line equations we can write in a minute, and we can see only thing Q is equals to KV. I'm 100% sure GATE will play again on this concept. Okay, again they will play in concept. They will give you any relationship in between Q or K, Q or V, K or V, and they will ask you the concept, the graph in between the other two quantity. So it's very good concept. What you have to remember, just write the equation of the curve, whatever is given to you, and Q is equals to KV. Eliminate the third variable which is not required, and here like they want K and V, so I eliminated Q, I put a K into V. Maybe they want K into Q or V into Q, so accordingly you have to eliminate and you have to check the option. Okay, so it's again will not take much time. It's a basic mathematics. Come to the third question. On a road, the speed density relationship is found to be V is equals to 70 minus 0.7 K, where V the speed in kmph, K is the density in vehicle per kilometer. At the capacity condition, the average time headway will be. They're asking to us to calculate the average time headway. In a whole transportation engineering, we have only one formula to calculate the time headway. That is what C is equals to 3600 upon HT, where HT is in second, and here you will get vehicle per hour. This is the only single formula you have to calculate the average time headway. So now definitely they are asking to us at the capacity condition, we have to calculate the average time headway, and they have given you some equation. V is equals to 70 minus 0.7. So here you can notice one thing, the relationship between K and V is given to you linear. Yes or no? It's a linear equation. If it's a linear relation, so I know in which one it's a linear relation. I know it's a green shield model. Yes or no? In a green shield model. So according to green shield model, what we know, Q max is equals to Kj into Vf upon 4. So if I draw the curve also for the green shield model, so you can see here we consider K. I'm not saying here, you can consider on y-axis also. And this type straight line graph, and here it's a Kj, and here we have a Vf, and this in between the K and V. Okay, so now one method is you write this equation V and we want Q, so you write Q is equals to KV, you do the first derivative and find the K value, accordingly you find the V value, and you can do it in that way also. I'm not going into that way. I'm just going to apply some small trick. Not trick, that's the only also concept. Now here you see in this equation, if I say if K is equals to 0, K0 means here. So now you can see speed is what? Vf, yes or no? So in this one, if I say, in this equation, if I say if K is equal to 0, so what can we say? We can say V will become Vf, put K is equals to 0, what you will get? Vf is equals to 70 kmph, right? Similarly, if you see here, if K is equals to Kj, what you are noticing? Kj means what beta? Kj means jam, yeah. If jam is there on the road, speed will become 0. So if K is equals to Kj, so we know V will be how much? 0. So if you put this condition here, K is equals to Kj, V is 0. So 0 is equals to 70 minus 0.7 Kj. So I can say here, Kj is equals to 70 upon 0.7. Kj is equals to 70 upon 0.7. This will be in vehicle per kilometer. So I know KJ is how much? 70 upon 0.7. VF is how much? 70 divided by 4. Can you tell me how much it's coming? 70 into 70 divided by 0.7 divided by 4. So it's coming how much? 1750 vehicle per hour. Right? Qmax meaning what, beta? Qmax meaning is nothing but capacity. Traffic capacity is what? Maximum flow possible. So here you know C means what? C is nothing but it's our Qmax. C is what? Nothing but it's our Qmax. So Qmax is how much? 1750, which equals to 3600 divided by HT. So you can see here HT will come how much? 3600 divided by 1750. How much it's coming? So it's coming almost 2.057 seconds. So here if you see, approximately option D is correct, 2.1 second. Okay, so here you can see approximately which option is correct? Option D is correct, 2.1 second. Okay, so option D is correct here. But again, what we have done, question have used the concept of green shield model with the microscopic characteristics, that is the space headway or time headway. Always how to approach the questions, what they are asking to you, first write the formula of that and see what is required and what is given to me. Right? Whatever given to you, put in the formula and then see what else is required, and for what else is required, what extra equations they have given to us. If you see here HT, I told you already, for HT I have only single formula in the whole subject. There should not be any confusion. HT for HT we have a single formula, that is the C is equals to 3600 by HT, and you can apply this thing in a minute. Okay, it will not take more than 1 minute if you are good in a, if you know the relationship between Q, K and V, and if you are good in a green shield model. Okay, again it's a hardly 30 to 40 second question. So this is the next question. Next question is related to the delay analysis. Okay, so this question came in a GATE 2019. I want to put one line here. This concept was firstly asked by the GATE 2006. After that, almost for 10 to 11 years, nobody have asked this concept. Okay. After that, again in 2017, the question appeared from this topic. And again in 2019, the question came from this topic. But in between, if I say 2006 to 2017, there was no question came from this topic. So mostly students left this topic in between that time. Nowadays, if you see, this topic is very important for the upcoming GATE exam. So you should not miss it. Okay. So what the question is saying, the Q length in number of, means Q length meaning is what? Number of vehicles versus time plot for an approach to a signalized intersection with cycle length of 96 seconds is shown in the figure. Okay, no problem. They have given some diagram. I will come to that. At the time t is equals to 0, the light has just turned red, meaning t is equals to 0, light is red, no problem. The effective green time is 36 seconds, during which vehicle discharge at saturation flow rate S in VPH. VPH meaning what? Vehicle per hour. Okay, vehicle arrive at a uniform rate V in vehicle per hour throughout the cycle. Which of the following statement is true? They have made the combination of vehicle arrival rate or saturation flow rate and the average delay per vehicle. They have made some combinations based on that in the option. Okay, so I will just tell you the small concept here for going to the delay analysis. In the delay analysis, we usually studied the three cases, but third cases. In the third case, it's difficult to find the delays. So mostly questions you will find in a case 1 or case 2. What is case 1? What is case 1 here? Case 1 is what? All the vehicles have passed when signal have just turned red. Meaning, or I can say when the green time just over, all the vehicle have passed beta. This is the first case. All the vehicle have passed when the green time is just over. That is my case 1. Our case 2 is all the vehicles has passed, but still we have some green time left. These are the two cases usually we consider. So if you remember, so the graph comes something like that. So if I say our graph comes usually something like that, this is my effective red time or this is my effective green time. Okay, means both the lines, this is my arrival line and this is my departure line. This is my departure line and here we have a time and here we have a number of vehicles. So if both the lines are intersect, just at when the green time just over. This is the first case. Second case is here time we have here. Again, initially it will be red. So vehicle will start arriving. Now you can ask me one question, sir, why you are making the straight line? The vehicles can arrive randomly. If it will be randomly, we will not able to do the calculation. That's why we have one assumption, vehicle arrival is uniform. You can see here question I also mentioned uniform rate, because if you will not mention, I cannot draw this straight line. Okay. Now after that, what happened? This is the red time. Red time is there. All the vehicles will come into the queue. But what happened? The green time just started after that. Let us say green time is up to here. Now what happened? Let us suppose the green time is up to G, but before the green time only, all the vehicles had passed and still you have some time left. Means this green time is still left. This green time is still left and all the vehicles had passed. Okay, this green time is still left and all the vehicles had passed. And in the first case, what happened? When the green time just over, all the vehicle had passed. I hope so you understood the difference in between these two cases. Okay. Now in a GATE 2006, the question came from this case, and now you see what is this question. Okay, now if you see in this diagram, what is happening? 0 to 60 seconds, they have given us effective red time, meaning red time what will happen? All the vehicles will come into the queue. After 60 seconds, what happened? Green time start, and green time how much is given to us? Green time is given to us 36 seconds. And you can see here at the 90 only, the graph have become 0, meaning number of vehicles become 0, meaning all the vehicles had passed. Meaning all the vehicle had passed here, beta. So this is which case given to me? Definitely this question is the second case. This question is the second case. Now you will ask, sir, you made something different diagram, but they have given something different diagram. No problem. Whatever they have given, just convert into my diagram. What we know. How to convert? Basic concept, beta. Basic concept, simple mathematics. How to convert? See here. On x-axis, what we have? Time. Y-axis, we have a number of vehicles. Let us say n, beta. And what is happening here? You can see up to 60 seconds, vehicles are coming because it's a red time. So let me say this is a 60 second. This is my 90 second and this is my 96 second. So what happened initially? Up to 60 seconds, the vehicle have arrived. How many vehicles have arrived? Here, they have given us 10. They have given us 10. And definitely, vehicle arrival will be uniform. So I will extend this line up to, let me say, up to here. Let me extend this line up to here. Right. So now after 60 seconds, what will happen? After 60 seconds, what will happen? The vehicle will start departing. Right. So definitely up to what time the vehicles are departing? Up to 90 seconds, because 6 seconds are still left. Meaning if I say here up to 90 seconds vehicles are departing, so my departure graph will cut this line somewhere here, and this time is still left to us. This time is still left to us, right? Now they are asking to us three things. One is the vehicle arrival rate, second is the saturation flow rate, and third is the average delay per vehicle. So let's talk about first thing, vehicle arrival rate. Let's talk about vehicle arrival rate. Vehicle arrival rate is what, beta? If they have given you diagram, it's nothing but it's the slope of arrival line. What is that? slope of arrival line. This is my arrival line. If I take the slope of this line, so you can see what is slope. Slope means tan theta. Tan theta means what here? Perpendicular upon base. So you can see how much it is in this triangle. If I say it is 10, right, and here it's a 60. So 10 by 60 meaning 1 by 6. What is the unit here? Any number of vehicle per time is how much, in which unit given to us? Second. So vehicle per second, but they are asking to us in VPH, in vehicle per hour. They are asking to us in vehicle per hour. 1 second. No? They are asking to us in vehicle per hour. So how can we convert in vehicle per hour? How can we convert in vehicle per hour? Just a minute. 90, 96. So here I have something like that diagram. Okay. This is our, this is the diagram. 10, 60, 90 and 96, and arrival rate is how much? 10 by 60. It meaning what? 1 by 6 vehicle per second. I want in vehicle per hour. So what I will do? 3600 by 6. How much it will come? It will come how much? It will come how much? How much? 600 vehicle per hour. So this is my arrival rate. Right. Next they are asking to us saturation flow rate. Next they are asking to us saturation flow rate. They have denoted this with V. That is S they are asking to us. So how can we calculate S? Simple, slope of departure line. Let me write here. This was the slope of arrival line. And this is slope of departure line. This is slope of departure line. So how can we calculate slope of departure line? This is my departure line. Yes, this is my departure line. I want slope of this, meaning I want slope of this. How can we calculate slope? I know slope is nothing but tan theta. So perpendicular upon base, meaning this I want this height. Meaning this I want this height. How can we calculate this height? Common sense beta. Corresponding to 60, how many vehicles they have given? 10. Because it's a linear relationship, so I can say corresponding to 90, how much it will be there? 10 by 60 multiply with 90. Solve how much it's coming. So it will come 15. So this will come how much? 15. So you can see slope will be how much? Perpendicular upon base means 50 upon, and this is how much? 60, and this is 90. So it will be how much? 50 by, it will be how much? 50 by 15 by 30, yes or no? It will be how much? 15 by 30. 15 by 30 means 1 by 2 vehicle per second. But they are asking to us in vehicle per hour. So that will be how much? 3600 by 2, meaning 1800 vehicle per hour. So what I got? I got arrival rate. I got saturation flow rate. Third thing they are asking to us, average delay per vehicle. Third thing they are asking to us, average delay per vehicle. Now, in average delay per vehicle, maybe you have heard the other formula also. Okay, but whenever they are giving you diagram, don't apply the formula because it will be lengthy. I'm not saying that will be wrong. You can apply the formula, but that will be a little lengthy. So here you see, this is my triangle. This is my triangle. If you take the area of this triangle and divide by the number of vehicle. So if I say this area, how can we calculate this area? Let me say this is O point, this is A point, this is B point, this is C point. So if I say triangle OBC minus triangle ABC divide by number of vehicle. Now here is the concept. Which number of vehicle? Which number of vehicle? Which number of vehicle? 15. Most of the students will say 15. No beta. Which number of vehicle we have to consider? Number of vehicle we have to consider which is corresponding to the completely green time. Vehicles have stopped, right? I still have a time. If in a 6 second other vehicles comes, that can be passed. I have no problem with that. So I still have a time, but vehicles are not in the queue. That's not my headache, right? So what we have to do? We have to see the number of vehicles corresponding to 96. That will be how much? Same thing again, you can see. Corresponding to 60, how much we have? 10. So corresponding to 96, that will be how much? 10 by 60 multiply with 96. If you solve, it will come 16. So here it will be 16. So always you have to multiply corresponding to the effective green time. That will be 16. So average triangle of area of OBC triangle, you can see half into base into height. Base is how much? 90. Height is how much? BC. BC is how much? 15. Minus area of triangle ABC, half into base is how much? AB. AB 90 minus 60, 30. Height is how much here? BC height is how much here? Again 15. Divide by 60. So if you solve this, it will come 28.125 seconds. It will come how much? 28.125 seconds. Okay, so three things we have found here. If you multiply with 15 here, it will come 30 seconds. Okay, if you multiply with 15, it will come 30 seconds. You can see now which option is correct. You can see which option is correct. We got how much? Arrival rate 600, saturation flow rate 1000, and average delay per vehicle 28.125. So you can see 28.125 is here. It's here. So but you check here, saturation flow rate here it's 1000, and here we have a 1200. How much we got? How much we got? Saturation flow rate. How much we got? How much we got saturation flow rate? Saturation flow rate, how much we got here? Tell me fast, how much we got saturation flow rate there? How much we got saturation flow rate there? You can say, I missed that diagram actually. So if you see here, saturation flow rate, how we calculated? The slope of departure line actually. Okay, the slope of departure line we have calculated. So it is something like that. So this one, right? Means this line slope we have calculated. This line slope we have calculated. This was how much? 15 number of vehicle. Means this you can see. This is how much? 15 height, and here we have a 30. 15 by 30, 1 by 2. 1 by 2. How much it's coming? It's a mistake actually. It's a mistake. I think it will be the 1800 here. Okay. It will be the 1800. So option will come option B. Misprint here it will come 1800, so option B will be correct here beta. Okay, the misprint, it's a mistype, so it will be 1800. So 1 by 2 and 3600 by 2, it will become 1800. Okay, so option B will be correct here. Only what you have to take here, what by which number of vehicles you are dividing. You are corresponding to 90 on 96. Always divide corresponding to 96, not 90. That's the only concept which I want to convert here. Okay, next you come, next question which came in a GATE 2015, and the question set by the IIT Kanpur, and this year also the organizing is IIT Kanpur. Just see how the beautiful question is this. A super speedway in New Delhi requires driver to negotiate turns with a radius of 335 meter. Radius they have given to us 335 meter and 33-degree banking. Banking means what? Banking means what? Banking means what? Anyone can tell me banking meaning what? Banking is nothing but it's a super elevation. Okay, it's a nothing but it's a super elevation. So super elevation is what? I hope all of you know, E, right? And they have given a 33-degree. So if you know, when we derive the formula of super elevation, we write tan theta itself is a E. So they have given you in the terms of theta. So tan 33 degree they have given to us. No problem. Given this information, the coefficient of side friction is what? Coefficient of lateral friction required in order to allow a vehicle to travel at 320 kmph. How much speed is required? 320 kmph is required. So what can we do here? 320 kmph is required. Now if you see the question, 320 kmph, is it looking to you practically possible? Is it looking to you practically possible? Not at all, right? 320 kmph vehicle is traveling with a speed of 320 kmph. It not looks good, right? It's not like a practical thing. Definitely, GATE also doesn't want practical thing from you here. GATE wanted to check your concept. How the GATE wants to check your concept here?
How? Let us say I am writing V is equals to 320 kmph. Now you tell what you will do. Most of you will say, sir, we know E plus F is equals to V square by 127 R. E they have given to us how much? 1033 degree. F they want from us. V is how much? 320 square upon 127 into R. R is 335 and F you will calculate here, right? And if you calculate, it will come 1.751 something. It will come 1.751 and you will say, sir, option A is very close to that and option A is correct. Yes or no? GATE also have done the same thing, beta. GATE also have done the same thing actually. But GATE also have done the mistake while giving the options here, and we are also doing the same mistake here. What is the mistake? If you remember, when you derive this formula, initially you get the formula E plus F upon 1 minus E into F is equals to V square by 127 R. We got this formula and we compare the value of E max and F max, then we notice that this denominator is almost equal to 1 and we ignore this one. But if you remember, there we have some condition. If I say for a plane terrain, we know E is equals to tan theta, and how much E maximum is possible in the plane terrain? 0.07. If you find the theta here, it will come approximately 5 degree. Meaning this denominator term is only 1 when theta is 5 degree or less than that. But if theta is more than 5 degree, you cannot say this denominator is 1. This is the concept GATE used, meaning you have to apply the formula here, E plus F upon 1 minus E into F V square by 127 R. Why we are applying this formula here? Because beta 1 minus EF term can be ignored when theta is less than 5 degree. If theta is more than 5 degree, we cannot ignore this term. Okay, we cannot at all ignore this term, right? So if you put all the values here, so you will get the value of F is equals to 0.685. So this is the correct answer. Okay, this is the correct answer, not 1.751. So GATE have given the marks to all students for this question in a 2015 because the options mistake is there. For you, you can say, sir, 1.75 is equals to 1.76. But in the terms of side friction, it's a huge difference. Okay, this much difference is not at all acceptable in the coefficient of side friction calculation. And also you can see speed is impractical, answers are also looking to impractical. As per IRC, the lateral friction value is how much? 0.15. But here speed they are given like a 320 kmph, so options are answer is also coming like impractical thing to you. So always take care about this concept. It's very simple concept, but while we give in the exam, we miss that concept. We miss that, right? Because many times we have applied the E plus F is equals to V square by 127 R. This thing doesn't come in our mind. And GATE will play with this. And why it's important for you, GATE 2015, it was organized by the IIT Kanpur. And this year also, IIT Kanpur is going to play. Okay, so definitely you have to play with them. They should not play with you. Take care about this. Okay, come to the next question. A super elevation E is provided on a horizontal curve such that a vehicle can be stopped on a curve without sliding. Assuming design speed V and maximum coefficient of side friction F max, which condition must be satisfied? This question was repeated in 2017. Before that, this question also have come. Exactly, I don't remember, maybe 2009 or 2010. This question has come before also, and again this question came in a GATE 2017. So this is a myth. The question will not repeat in a GATE. This is the example in the front of you. Question repeats in the GATE. Only that time the option they have given different. Now the option they have given different. But correct option they have given same. Okay, don't think the correct option is also they have made in a different way. No. Correct options they have given in a same way. But just play with the small language and all. That's it. But whole question is same. Now see what question is saying. A super elevation E is provided on a horizontal curve. Okay, if we have provided the super elevation, let me say this is my inner side and this is my outer side of the horizontal curve. So definitely if it's a super elevation provided, so definitely outer side will be on higher level compared to the inner. I know this thing, right? definitely it will be a higher. Definitely it will not be this much higher. I'm just showing you for the understanding. Right. Let me put my vehicle on this. Let me put my vehicle on this, and let us say this is my vehicle which is standing on this road. Right. Assuming design speed is V and maximum side friction is F. Okay, let it be. Let us say this is my super elevation theta, or we say it's nothing but E. Okay. Now, how many forces will act on this vehicle? All of you will agree with me, sir. One will be self-weight, right? All of you will agree with me. One will be self-weight W, and other will be what? Other will be what? Most of the you will say, sir, it will be centrifugal force, right? So P is equals to mv square by r. But a question said to you, the vehicle can be stopped. Vehicle is stopped, meaning speed will be how much? Zero. If speed is zero, centrifugal force is also become zero. No meaning of centrifugal force. Other than what will be there? Lateral friction will be there. In which direction? Inner or outer? Definitely you see some friction always act in inner direction. No beta. Here the vehicle is stopped meaning the vehicle will try to slide inward. So friction always act in opposite direction. So friction act in outward direction. F into N. Let me write here F max because question said to you maximum is F max. Okay. So these are the forces acting on that. So here you know the simple mathematics. If this angle is theta, and this is 90, so if I draw this thing, theta 90 minus theta, this will also 90 minus theta, this will become theta. So this is W, this component will be W cos theta, and this component will be W sin theta. Now, what I don't want the vehicle should be slide. So when the vehicle should not be slide, definitely when F max N is greater than our or equals to W sin theta. When this outward force is more than the inner force, definitely my vehicle will not slide. So now you can see F max is equals to N is what here? N is W cos theta should be greater than equals to W sin theta. W to W cancel. It will come F max would be greater than equals to sin theta by cos theta tan theta. So I can say here F max would be greater than or equals to tan theta is what? I know it's nothing but it's my super elevation. So which option is correct here? E is less than the F max. So you can see here option A is correct. Here you can see option A is correct. So I will say to you, remember this result. Remember this result. If question repeat, so you can put the answer just by seeing the option. Try to remember this result. E must be less than F. Okay. So then only the vehicle should not slide inward. That's the condition for that. Again, I am saying the question has been repeated. Again, if this will repeat again, it won't be a surprise for me. It can be repeated again. Okay. Next question you see. Again, this question came in a GATE 2015. This question came in a GATE 2015. The topic from which the question came, mostly students don't know this topic also. This type of topic is also there in a transportation engineering. What the question is saying, a sign is required to be put up asking drivers to slow down to 30 kmph before entering zone Y. You can see they have given something zone Y in a figure. Okay, on this road, vehicle required 174 meter distance to slow down to 30 kmph. This sign can be read by 6x6 vision drivers from a length of 48 meters. No problem. The sign is placed at a distance of X meter from the starting of zone Y. Okay, no problem. So that even a 6x9 vision can driver slow down to 30 kmph before entering the zone. The value of XH. Now I am giving you 30 seconds. All of you just try to understand what the question is saying to you. Okay, all of you try to understand what the question is saying to you. Question said here two pupils are there. One have a vision 6x6, other have a vision 6x9. The pupil, the person who have a vision 6x6, for that the sign is put at a 48 meters distance, and for the person who have a 6x9 vision, for that we have to find. And one thing question said, on this road vehicles require 174 meter to slow down to 30 kmph. So if I say beta, this is not sign of movement, it is direction of movement. Okay, this is direction of movement. So if I say, let us say I have a vehicle which have a normal vision. Normal vision means, if you remember, I'm telling you one thing. If I say any person have a normal vision, it's a 6 by 6. If you go to the doctors for an eye checkup and they will give you some number, right? They will give you in the form of 6 by 6 or 6 by 9. You say, no, sir, plus 1, minus 1. This is the lens power. This is the power of lens. Okay, this is not your vision. The vision will be always defined with reference to 6. Okay, 6 by 6 meaning is what? 6 by 6 meaning is what? If I say a person have a normal vision, which means the person can be read a letter of 8 mm size approximately from a distance of 6 meter beta. This is the meaning of 6 by 6. Meaning, if I am able to read 8.5 mm letter from a 6 meter distance, my eyesight is normal. Okay, now what is the meaning of 6 by 9? 6 by 9 meaning is what, beta? If normal person can read from a 9 meter, now you tell, if normal person can read from a 9 meter, if any person have poor vision, he have to come to close to that or far away? Definitely he will come close to that. Meaning, if normal person can read from a 9 meter, the person who have a poor vision means 6 by 9 vision, he can read from a 6 meter. This is the meaning of 6 by 9. Okay, so this topic comes in traffic characteristics. If you see the driver characteristics, we have 4 types. So in a physical characteristics, we have a vision. So from the vision characteristics, GATE formed a question. Only one time the question have come from this topic, but it's a common sense. Okay. So now if I say this is the normal vision person, means 6 by 6 person vision pupil person, for him 174 meter distance is required, and the sign is placed where? The sign is placed at a distance of 48 meter. Right? Now you tell if this person now becomes 6 by 9. Now this person will become 6 by 9. You tell this sign will be this side or sign should go this side? Definitely sign should come to close, right? Definitely sign should come to close. So let us say I shifted the sign here. Let us say I shifted the sign here for him. Right? Now for a 6 by 6 person, the distance is how much? 48 meter. For 6 by 9 person, how can we calculate? Common sense here. For 6 by 6 person, 48 meter. For 6 by 9, apply the unitary method. 48 divided by 6 by 6 multiply with 6 by 9. So if you solve, how much it will come? It will come 32 meter. It will come how much? 32 meter. This distance will be how much? 32 meter. Now what we have to find? The value of x. What is x? X is the distance between sign and start of zone Y. Now for a poor vision person, what is x? This is x, beta. This is x. So what will be x value? Anyone can tell. 174 meter is required to slow down. Here to here distance is how much? 174. And this is how much? 32. So if you solve this, how much it's coming? It's coming 142 meter. It's coming how much? 174 minus 32. It's coming 142 meters. So answer was 142 meter. This is again 2 marks question. Okay, again this is a 2 marks question, and it's hardly the need of hardly 3 lines. But only thing is you must know the meaning of 6 by 6 or 6 by 9. If you don't know, so definitely you will be in trouble in this question. And again I am saying IIT Kanpur play with the new topics. Okay, the topic which you are thinking to skip, 100% the question is going to come from this that topic in a GATE upcoming year. So now don't miss any single topic. If you are feeling had any difficulties and all, that's other thing. But don't try to skip anything or go ahead with the topics which you are not coming regularly. The GATE trend has been changed. The topic which is not expected are coming in a GATE exam nowadays. So that you have to take care. Okay, this is the example of that type. So one more question. This question came in a GATE 2022. It's very simple question. Just I'm taking because the mostly students don't know the meaning of shock wave, because the questions have hardly come from this topic. Assuming that the traffic on a highway obeys the green shield model, the speed of shock wave between the traffic stream P and Q H. Okay, so mostly students will be here. What is shock wave? Nothing. Don't forget the shock wave, whatever it is. Okay. They are said to us green shield model. I know what Q is equals to KV. So I want speed V is equals to Q upon K. They have given me two. One is P and one is Q. So I can say dQ by dK. I can say dQ by dK. Now, if you ask me, sir, what is the meaning of shock wave? Usually, this concept used in a vibration analysis of the bridges and all. Okay, in the bridge and all, for doing the vibration analysis, this concept used. So, most in the masters in MTech, the most students study even this. In the BTech, it have a not much relevance. So I'm not going in a deep, but only thing is when the flow will be suddenly changed or density will be suddenly changed, the shock wave produced. If the speed is positive, if speed coming positive, we say shock wave is moving in the direction of traffic. If V comes negative, we say shock wave is moving opposite to the direction of traffic. If I say V is 0, we say it's a stationary shock wave. We say it's a stationary shock wave. That's it. Okay. So if you see one time in a GATE 2017, the question have come, they have plotted something like graph. Okay. So here you can see the actually all options was correct, because in all the options, if the flow is equal, then definitely shock wave will be stationary. If it's going down, so it will be negative shock wave, and it's upcoming a positive shock wave. You can check the GATE 2017 or 18. One question have come from this concept. But here if you see, the speed of shock wave V is equals to dQ by dK. Q is what here? QQ minus QP divided by KQ minus KP. That's it. Right. So QQ how much given to us? 1800 minus, you can say, sir, why you are writing KQ? Yeah, you will write this also, no problem with that. Okay, you can write. But if you are starting from Q minus P, you cannot write again in a denominator P minus Q. It's your choice. QP is how much? 1200. K. They have given us K? No. They have given us a speed 60 and 30. I know now. K is equals to Q upon V. I can say here QU, QQ upon VQ minus QP upon VP. Just put all the values here. So if you put all the values here, let me solve this side. V is equals to 1800 minus 1200, 600. QQ upon VQ. How much? 1800 by 30 minus QP upon VP, 1200 by 60. So if you solve this question, you will get here 15 kmph. You will get the answer 15 kmph. Without calci, you can solve this question. That was the beauty of GATE 2022. Most of the questions was set in such a way you doesn't need a calculator. Calculation was very easy with the manual, and you can solve the questions with that. So just shock wave meaning is 3 lines you have to remember, this and this. Okay, the question will not go beyond this one, right? Sure. You can ask me one thing, sir, how this Q is changing. It's not your matter of concern. Okay, you can ask me, sir, how this in this one, the 1280 60 there, how 1830, that's not your concern. Okay, they have given the flow on the road, things are changing. It may be due to any road condition or any conditions are possible. Okay, so we should not go into that. Just solve the question, get the marks. That's it. One more question. This also came in a GATE 2022. This is again one of the most important topic in a GATE, that is Marshall mixed design. Marshall mixed design, right? Most important topic. Mostly questions comes from this topic. Okay, what is the question? The question is, it is given that an aggregate mix of 260 gram and 240 gram of fine aggregates. Okay, specific gravity 2.6, 2.4. The bulk specific gravity of a mix 2.3. Percentage volume of air voids. What is that? I hope so you know. That is VV percentage they want. What the formula? GT minus GM upon GT multiply with 100. I always say whatever they are asking to us, write the formula of that first. Now they are asking to us VV. I want GT and GM. So you can see bulk specific gravity of the mix. GM they have given to me already 2.3. Ultimately what I want GT. Now maybe you studied the formula of GT W1 plus W2 plus W3 plus WB upon W1 upon G1, W2 upon G2 plus W3 upon G3 plus WB upon GB. Right, now you can ask me, sir, where is it bitumen they have not given? How can we apply? It's not your matter of concern. Yeah. whatever they have given to you, put that, other consider 0. How much they have given? 260 plus 240 divide by how much? 260 divide by 2.6, 240 divide by 2.4, right? So how much it's coming? You can say it's coming 500 and 2.6. Again you will solve 100, 200, 200. It will become 2.5. It will become 2.5. One more doubt may come in your mind, sir. You have studied maybe one more formula, 100 upon W1 in percentage divided by G1, something like that, right? So this formula you always apply when the weights are given to you in a percentage of. Okay, if they have not given you percentage, they have given absolute value, you have to apply this. So VV percentage is equals to GT is how much? 2.5, 2.3 divide by 2.5 multiply with 100. How much it's going to come? It's going to come 8%. Okay, it's going to come how much? 8%. Again, this is the example. You can see no calculator is required. Without calculator you can solve this question, and hardly it will take 15 to 20 seconds if you know the thing. Okay, so that's it from my side, but before that I'm just telling you something which will be important. Like, if you are in the last day of the GATE exam, if you have in last few days back, if you have time, just horizontal alignment. Okay, horizontal alignment, and second is traffic flow characteristics. Traffic flow characteristics and Webster method, Marshall mix design. These are the 4 topics. From that, mostly we are seeing the question almost every year. Horizontal alignment means super elevation, extra widening, etc. Traffic flow, you know, Q is equals to KV formula. Webster method of signal design, all of you know, and Marshall mix design. So these 4 topics, usually we have seen the questions from these 4 topics in a GATE exam. Okay, most of the year, last years we are seeing the trend of these topics. So these topics you should not miss at any cost. Mostly question means almost, if I say 5 to 6 marks are here. Okay, 5 to 6 marks are coming from here. 2, almost 7 marks. Not 5 to 6, I should say 7 to 8 marks. 7 to 8 marks are coming from this. Yeah, 1 or 2 marks will be there. They can play with you. Sometimes they ask the database questions. Sometimes they ask you other things also. So data questions, if they're asking to us, so no need to worry. Most of the students, even the IISc GATE toppers and all also, no one is going to remember those data. Always the questions which are coming the concept basis, you have to run behind that. You should not say, sir, they ask, like if I see in GATE 2015, they ask the question from a signal design. That was the some IRC standard, IRC specification they have asked to us. So nobody remember, because hundreds of specifications are there. All the specifications, all the values cannot be remembered. Okay, similar like in RCC, don't remember means all the values and all. We know whatever the concepts are coming, those formulas we remember, that's it. Similarly here, no need to worry about that, sir. They ask a one-time traffic capacity value. Beta, okay, they asked. But if they again ask, no need to worry. Don't let it be. Yeah. We cannot be remember all the values. It's very difficult because you have 13, 14 subjects. If you go behind, remember the values and all, your time will be wasted. And most of 99% students don't give the answer of that question. So no need to worry about that. Just go with the conceptual questions and complete the questions. Okay. So that's it from my side for this session. Hopefully almost 9 questions we have solved in this one. And most important topics, the question comes, which I have covered in the last one are, and you can see we don't need more than 1 to 2 minutes for solving any question. It's not like a trick if I say, it's like all concepts, but concept we have applied in a other way. All of you know concept, but how are we understanding those concepts? That's the only game in this one. If you have any query in any question or any concept, if you have any doubt, okay, from this one, whatever 9 questions we have discussed, you can put in a chat box. I will reply you in as soon as possible. Alright guys, thank you. Have a nice day. Thank you.